In this video, I'll go over depth first search. The algorithm is given right here. It uses a stack and a set data structures. The input to the algorithm is the starting node, in this case start v. I think this algorithm right here has, I need to make a minor adjustment to it. This statement visit current v should be after this if statement, or it should be inside the if block. So that's what I'm going to place it basically. So let's go over this algorithm. The starting vertex is A. So the algorithm, what it does, it places that starting vertex into the stack. It's right there. A is inside the stack and goes through this while loop. If the stack is not empty, which it is not, it will pop it, and A is popped and placed inside current vertex, current V basically. There's A. And if this current A is not in the visited set, it is not in the visited set, you are going to visit it, and by visiting we'll just print it, and then add it to the visited set, and then go through this for statement. For each vertex adjacent to A, push them on top of the stack. So what are the vectors, vertices adjacent to A? B and D basically are adjacent. We'll push them on top of the stack, D and B. We are done. We go back to the top of the loop, the while loop. Stack is not empty. We'll pop it. So B will be popped out of the stack. That's the current vector basically. And go through the statement. If this current vertex B is not in the visited set, it is not in the visited set, we are going to visit it, print it, and then add it to the visited set. There's B. And then moving on to this for statement. For every vertex adjacent to B, we push him on top of the stack basically. So what are the vertices adjacent to B? Adjacent to B we have A, E, and F. And by the way, this B has been popped in the previous step. So adjacent to B are A, E, and F, and they're all placed on top of the stack. We go back to the top of the while loop. Stack is not empty. We pop what's on top of the stack, and in this case it will be A, so current will be A. Stack is popped. Is A in the visited set? Yes, it is already in the visited set, so we won't execute this conditional statement. We go back to the top of the stack, pop another element. F is popped, so the current vertex is F now. Is F in the visited set? No, it is not visited. Right there, that's visitation is after this if statement. Visited and then added to the visited set, and then for every vertex adjacent to F, push it on top of the stack. So what are the vertices adjacent to F? Basically, it is C and E, but E is already in and B as well. You have C, E, and B. All of them actually are placed on top of the stack right here. You're done. You go back to the top of the loop basically, and you pop another element from the stack. It is B. So let me just make sure that we have everything here. There's B. We'll remove it and place it as the current vector. But this current vector is already in the visited set. There's B. So nothing happens. You go back to the top of the stack and pop the next element, which is C. So C comes down. C will be the value of the current vertex basically. Is C in the visited set? No, it is not in the visited set. You visit it by printing it and place it in the visited set. There's C. And then for every vertex adjacent to C, push it on top of the stack. So what are the vertices adjacent to C? The only thing that you have is F. F is pushed on top of the stack. and then you go back to the top of the while loop. Stack is not empty. You pop the next element, which is F. You bring it into current vertex. F is already in the visited set, so nothing happens. You go back to the top of the loop and basically pop the next element, which in this case will be E. E is not in the visited set, so what you do, you visit it. You visit the element, and which is right here, and then add it to the visited set, and then add all the vertices adjacent to E on top of the stack, and that would be B and F. They're right there. Go back to the top of the stack, pop the stack. B is out. B is the current vertex right now. There's B. B is already in the visited. If current V is not in the visited set, but B is already in the visited set, the conditional statement and the for loop will not execute. So go back up to the top of the loop. Next element is popped from the stack, and that is F. F also is in the visited set. Nothing happens. You go back to the top of the loop basically, and E once again is popped. E is in the visited set. Nothing happens. You will go and pop the next element off of the stack, and in this case it's D. Current vertex is D. Is it in the visited set? No, it is not. Visit it and place it in the visited set, and then for every vertex adjacent to V, push it on top of the stack. What are the vertices adjacent to E? There's only A. A is pushed on top, and then you're going back to the top of the stack. Stack is not empty. A is there. You pop A. Current vertex will be A. A is visited, so nothing really happens. You go back to the top of the stack, but it is empty. So here is how you have visited the nodes in this graph. That's the order you have visited it. So it is, and it is important for you to see the depth first search. It is A, B, F, C. That's one depth first search all the way down to the end, and then E, and then it goes to C, E and D. So it will be E and D are after that. It is A, B, E and AD. These are the vectors that have been visited basically, all the nodes basically.